information. This is a stupid question, or something like that. The French researchers were very dismayed to find that the majority of the children gave a numerical answer, mostly 26. When they talked to the children, one child said, well, 20 multiplied by 6 is 120. That's clearly too old. 20 minus 6 is 14. That's too young. 20 plus 6 is 26. Yeah, that's about right. So they would say 26. Another more imaginative child said, maybe his parents gave him an animal on each birthday, so he would always know how old he was. Now, what is fascinating is that recently, last year, this question was put on a test in China, 5th grade test, and it gave rise to a great deal of controversy. And if you go to this man's blog, Presh Talwalkar, if you check out his blog, he describes the global reaction to this shocking event. Children would be asked to answer this nonsensical question. The authorities who had put the question on the test, they defended its use because they said they wanted to test critical thinking. Now, again, many people, when they heard of the French results, said, oh, this is something strange about French people. It wouldn't happen in our country. And then they replicated the study and found that it did happen in their country. So these kinds of results tend to be very similar regardless of the country where it's done. A French journalist wrote a whole book about this because she was absolutely shocked. She said, how can it be that ordinary French children are showing such irrational behavior? What's wrong with our teaching? Yes.
Yeah, I just had a question. Has anyone studied or asked this question to people who have not been to school or not
I don't think that has systematically been studied. I've done a few informal individual interviews, and people who, without a lot of formal education, give you what I would call a common sense, tend to give a common sense answer.
So that's showing that school is successful at teaching.
Exactly, exactly. And actually, there are quite a lot of studies of this and similar problems which show that it gets worse the longer the children have been at school.
Can I comment?
Yes.
Karen, to your question, Yuki Ueno, when he was alive in Japan, he and his team were asking similar questions to children in Japan and also in Nepal. And in Nepal, people were not schooled. They were asking shopkeepers. These nonsensical problems like a cup of coffee cost $50 was the cost of 5 cups of coffee. The Japanese children very obediently did all the computation right without questioning, just as what we were talking about. But the Nepali shopkeepers who were practically illiterate, what we call illiterate, they said there must be a catch. This is never that kind of a situation. There must be a reason we are trying to catch. So that sort of thing is happening, but these studies are not written in English, so we cannot give you more than that.
It's probably the reason why they weren't published those things. Because the big mathematics educators who like to do this.
It was published in Japan, in Japanese, and some of it is not coming out. That Ueno has died 2 years ago. I might be able to track it down now. I remember it coming up in
also an earliest. There are also old studies by the Russian psychologist Luria, who talked to unschooled peoples and would ask a question like, if a man shot 4 bears in the morning and 2 bears in the afternoon, how many would that be altogether? And they would say things like, nobody could shoot 6 bears in one day. So this contrast is very clear. Of course, the question is, what is the implication? I would argue that one implication is that it's not good for children to grow up, to be schooled into these habits. Okay, so now I'm going to talk about what I call world modeling problems. So in this case, you have a description in words.
Shall I please do it?
Yes, sir.
Let us just discuss about the previous one. If we have been asking about such type of questions, as we have seen that there are 3 types of word problems: puzzles, then which doesn't make any sense, and third is about modeling, right?
Yes.
So can we consider this type of question as making no sense, or shall it be considered as a critical thinking?
Well, it is nonsensical in a sense. The critical thinking comes from knowing that well, it's more to do with what has been called the didactical contract. What is the implicit contract between the student and the teacher?
So does it mean what?
But it's a question of what is considered an acceptable response. And some children will conform to the implicit rules, which say, for example, responding by saying this is nonsense is not an acceptable response.
Being a math teacher, I can never accept such questions. For example, if I'm asking a word problem like a man has shot 4 bears in the morning and 2 in the evening, my expected answer should be 6 bears in a day.
Yes.
Right? Being a math teacher, because it's quite realistic.
Yes.
But if you want to consider in some other perception, I can consider it as a second type of word problem,
Yes.
which doesn't make sense. And
Yes.
man can't shoot
That's
6
right.
bears in a day.
Yes.
Can I add?
Yes.
So, see, I mean, broadly speaking, you can look at word problems into 2 categories. One is the application in which you actually solve the real world problem. Another, just a mental manipulation.
Yes.
For example, the kind of problem, the where problem, that's not an application-based problem. It's a mental manipulative problem.
Okay.
The methods are
Right.
known.
Yes.
So, I mean, we need to make distinction between these two.
Yes. I agree. You could say that sometimes a word problem is just a way of presenting, let's say, an algebraic problem without having to use algebraic symbols. Or it's another way of presenting a calculation. So instead of just giving a raw calculation, 4 plus 2 equals what, you present it. Yes. Now, yes.
With regard to this particular problem of the so-called nonsense problem, isn't it the ability of the child to take a decision that this is nonsensical, showing us that the child is quite versed with the mathematics required? So the child has to arrive at the conclusion that this problem sounds nonsensical. This means some data is missing, in some way the child was supposed to solve that. And therefore the child is either versed with the algorithm or the method or whatever we want to call it as, but then putting it in the category of nonsensical itself is a critical skill of the child.
Yes, I do, but it's a question of what if the child is socialized to the mathematics classroom, what is acceptable is very limited. So if we think this is a very simplified description of the modeling process, you have a situation in the real world. You set up a model in the form of mathematical relationships between quantities in the situation. You run the model to find the mathematical implications. And then you interpret the result in terms of the situation. So if we take a very simple and I would say uncontroversial word problem, Joe has 6 bananas and his brother Jim has 5 bananas. How many bananas do they have altogether? So the mathematical model is 6 bananas plus 5 bananas. Takes, you do the computation, 11 bananas, and the interpretation is that Joe and Jim have 11 bananas altogether. Now, think about what happens if you change one word in the problem, and instead of bananas, it says friends. Joe has 6 friends, and his brother Jim has 5 friends. How many friends do they have altogether? Now, what a mathematician would say is that when you want to count the number in the union of 2 sets, you can add the numbers in each set only if and only if the 2 sets are discrete. So if this question was about friends, you would have to say, well, we need to know how many of these friends are friends of both Jim and Joe before we can answer the question. So this is the kind of distinction I want to make. A situation where the model is straightforward and a situation where the model is needs much more interpretation, nuanced interpretation. So since 1992, my interest is in word problems where the modeling is not straightforward. Back in 1992, I took some questions to some schools in Ireland. And this was one of the questions. During December, a store sold 124 birthday cards. About how many do you think it sold in January, February, and March? Now, a reasonable answer to this, I would argue, is to multiply by 3, and what you get, 372, about 372 birthday cards. If you sell so many birthday cards in 1 month, you will sell about three times as many in 3 months. Again, just changing one word, change the word birthday to Christmas. Now, the first question, essentially all the students said about 372 cards. The second question, about 60% of them said about 372 cards. Some of the really bright students in the class made a correction because February is shorter than the other months. They were also asked to write comments, And some of them wrote comments like, well, maybe about 100, or maybe about 50, because some people who like to save money buy their Christmas cards in January when they're actually. So, and we would consider that what we call a realistic response. Anything that takes into account the reality of the situation being described.
Excuse me.
Yes.
Actually, in schools, when we give word problems to children, we don't generally give them so much time to think whether the
Yes.
shop is selling Christmas cards or birthday cards.
Yes.
So it's like we are used to give them some situation. Okay, and again here we have not mentioned that they are selling the same number of cards in every month. So very few students ask about these kind of questions. Otherwise, students are used to just read and calculate and get the answer.
Yes.
So I mean, we are not giving them time to think.
I think time is. Ashwini, am I saying this? Yeah, sorry, Ashwini. You mentioned that you emphasized to the students that they must use logic. And as you say, in order to think carefully about this problem, you need time.
Yes.
And this is especially serious when they are doing timed tests, because they are deliberately given little time. The fast part of the test is to see how quickly you can answer. It's not about how logically you can answer. Yes, so I totally agree that this question of timing is very important. But if, for example, in your teaching, you gave them both of these problems and encouraged them to think logically about what is the difference between birthday cards and Christmas cards. Birthdays are spread uniformly over the year, therefore you expect the sale of birthday cards to be more or less uniform. Christmas is at a particular month of the year. So time to think. Children should be given time to think. When I got interested in these questions, one of the first anecdotes, which came from a friend of mine in the States, he said he was in a classroom one day and the children were asked, how do you divide 5 balloons between 2 children? And one of the children said, could I have a pair of scissors? So we made a variation of this problem. A grandfather wants to share a box of 18 balloons among his 4 grandchildren. How many balloons will each child get? And this was part of a set of about 10 problems, which we gave to students in several countries, and colleagues replicated the study in many other countries. And as I said, generally speaking, the results were very consistent across different countries. In Europe, in South America, in Asia, wherever they were, these tests were done. And in this case, they would always have been, the tests would always have been in the mother tongue. So what you would like children to say in answer to this question is that each child would get 4 balloons and there would be 2 left over. Maybe you could just decide by chance what to do with the remaining 2. Or there are many different ways of deciding that. The most interesting response I got, and I'm really kicking myself that I didn't take the chance to ask a particular student more about this response. The student said each child would get 4 balloons, but the real answer is 4.5. This is another very striking example from a math educator in Israel. If you had one beaker of water at 80 degrees and another beaker of water at 40 degrees, and you add them together, what would be the temperature for them together? Can you guess what is the most common incorrect response? I mean, it's obvious, isn't it? You've got two numbers, 80 and 40, and you're adding. Has to be 120, right? Wow, going more than an hour already. Again, this is another of my favorites. A runner's best time to run a mile is 4 minutes and 7 seconds. How long would it take the runner to run 3 miles? Now, when we gave these written tests, generally speaking, the instructions on the test would say some of these answers are not as obvious as they might appear. So think carefully about your answer, and then we had a space where they were invited to comment on the question. Despite that, with a question like this, a very high majority of children multiply by 3. Instead of saying something like maybe about 14 minutes for 3 miles. Now, the point, one of the major points here is these children know, almost certainly, almost all of these children know that a runner cannot keep up the same pace for 3 miles as they can for 1 mile. Right? They know that, but this knowledge is compartmentalized. It is not considered relevant to the answering of this question. This is another example I came across. It actually comes from Lewis Carroll, the author of Alice in Wonderland, who was a mathematician, was very fascinated by mathematical puzzles, and in particular about the relationship between language and mathematics, and the way people use language in mathematics. And he actually wrote this when he was still a child. He wrote it in a little magazine that he and his siblings used to produce in the house, in their own house, for their own amusement. So if 6 cats kill 6 rats in 6 minutes, how many will be needed to kill 100 rats in 50 minutes? He then gives a very interesting discussion about how the answer to this depends on the assumptions that you make about the reality of cats killing rats. So the standard answer based on just proportional reasoning would be 12 minutes. But then he gives alternative models where the answer is 13 minutes or 14 minutes. Because when most of the rats have been killed, let's say there were 4 rats remaining to be killed by the 12 cats or whatever number of cats there are. How do a large number of cats kill a rat? Do they have to divide? Do you have to have fractions of a rat? And does it matter whether it's the front third, the middle third, or the back third, and so on and so on? So he raises, it's written in an amusing way, but it makes a serious point. And the point is that the model is dependent on the assumptions that you make. Any model of any physical situation is going to be dependent on your assumptions. And I think this is he was one of the first people to very clearly make that point. So now I want to come back to something which was not a focus of our earlier work. We focused earlier on our reaction to what we perceived as an infringement on the natural right of the child for mathematics to make sense, to be logical. And we had a very strong reaction to that. Like the French journalist who wrote a whole book on how old is the captain question, that it is against justice for a child that they're not presented with mathematics, or they're presented with mathematics in a way which violates sense making. Another whole area of research, and I don't know that very much of this research has been done, is to look at word problems as a mirror on society. And I'm just going to take a couple of examples from the American context. This is a very standard example. You will see hundreds of examples like this in American textbooks about someone who bought 4 shirts costing a total of $134. What is the cost of one shirt? Do you have a reaction to this? In one sense, it's a sensible question. It does mention that each shirt costs the same amount, so divided by 4 is okay. But what do you think about giving this question in a classroom where the children come from families which don't have that kind of money? The textbooks generally are written by reasonably wealthy, middle-class people. And the items that they write reflect their own circumstances and their own view of society. Personally, I would not want to use a question like this with a class containing of students whose families don't have a lot of money, unless I specifically wanted to raise the issue about, is it reasonable for a shirt to cost this much? You know, a teacher that we work with in Portland, he works in a school where he has a degree of flexibility to teach the way that he wants to teach. So he had time, the question of time. He was able to take time and do a project that took a couple of months. And the project had a very simple beginning. He asked the children to look at the labels on their t-shirts. Most of them were wearing t-shirts. And see where the t-shirt was made. Then he got a world map and he put pins in to show the range of different countries that these t-shirts came from. Then he looked at the history of t-shirts. T-shirts were developed as a practical working garment in factories in the east coast of the United States at the beginning of the 20th century. So he got a lot of information about these factories, how much people were paid, what the cost of food was. He had historical photographs. He had a photograph of an extended family where everyone from the grandmother to the youngest children was working in the factory. He found out how much food cost. He had the children calculating the budget for a family for a month based on the data available. He then, the project went on and on. He talked about the development of unions. And finally, at the end, he talked about sweatshops, where these t-shirts are made, what the people who actually make the t-shirts get paid, and so on and so on. So that was, and he has written up this project. If anyone is interested, just get in touch with me and I can. Yes.
Just to clarify, you're mentioning that he did all of this and the children did the calculations.
I'm sorry?
I'm saying that the author, the maths educator did all of this work and explanation and the children just did the calculations. Is that right?
Well, he gave them the data and the background information. Yeah, they did some of the research themselves, yes.
Okay, but the children raise any questions regarding because it's like, okay, one person does all the talking, now because and the children just do the first like so yeah, they just do the technical calculations.
Yeah, but he also another aspect of this project was that there was a lot of role playing. So he took the role of the manager of the factory. They took the role of the workers. At one point, he had to inform the school, if my students are parading around the school with placards saying fair wages, don't be alarmed, this is only a role-playing exercise. So the children were heavily involved in terms of really emotionally getting into the roles of these workers. So it wasn't as passive as you were feeling.
Excuse me, sir.
Yes.
Can you say that it's a type of interdisciplinary education?
Yes, absolutely.
It's a very good point.
Yes. Actually, we were talking earlier with Arundam.
Okay.
He and I have the same thought that if you want to get mathematics into TIS, you have to establish that mathematics is a social science. We're going to think about that. So absolutely interdisciplinary.
This is the way actually we can make children understand how maths has been related to so many different disciplines.
Yes.
Actually to their real life. So.
Yes. So he was talking about economics, politics, history, yes, geography.
Many things are
Many things, yes. And shouldn't all elementary education be interdisciplinary? So this is another example that has been discussed quite a lot in the States. This is a problem that's on a written test. So one bus ride costs $1.50, or you can buy a weekly pass for $16. So in order to get the bus rides to go to and from work, is it better to pay the daily fare, $1.50 each time, or buy the weekly pass? What the children were supposed to do was say 10 single fares will cost $15. Therefore, it is cheaper to do it that way than to buy the weekly pass for $16. Now, do you see any problems with that particular model of the situation?
Context matters a lot, I think. For instance, in some of Indian contexts, the working days themselves will be 6
Yes,
instead of 5.
yes,
And for people like, for women who work as maid servants, for example,
yes,
the working days could be all 7.
yes.
And therefore, for them, the deal would be completely different than what
Exactly.
they explained.
Also, yeah, and if you're talking about a working maid, they will have several jobs.
Yes.
So it's not just, so the idea that it's, when you go to work, you work 5 days, you go to work in the morning, you come home in the evening. That may be true in the world of the person who wrote the problem. And this was critiqued by an African-American scholar in the States, because the points you raise about the Indian context are similar to the points that apply to African Americans and other people in the States. So,
Or suppose you ask him in Luxembourg, where all mass transport is absolutely free for everybody.
yes.
This is right, yeah, because it kind of presupposes that the government is too poor to provide, this word problem, it presupposes that the government is too poor to provide free transportation.
Yes.
To the people.
Yes. But think about the implications of this. This was given on a standardized test. A student who gave the preferred answer would gain a mark. A student who didn't would lose a mark. And that would be highly correlated with the socioeconomic status of the student or their personal circumstances. So this form of question is highly discriminatory.
What I'm also interested in is, generally in a very consumer-intensive world, buying something at bulk is always a cheaper thing. That's a general thinking.
Yes,
And even on that count, somebody may say that buying a weekly pass is cheaper,
yes,
even without getting into any
yes.
mathematics.
That is unrealistic, actually, yes. A weekly pass, yes. You're right, but there are so many problems, difficulties with this particular item. So this is what an African-American scholar wrote about this. He analyzed this problem and interviewed African-American students. When African-American students were interviewed, they transformed the neutral assumptions into their own realities and perspectives. So a job might mean making several bus trips every day and working more than 5 days a week, exactly as you said. If items of this type are used for assessment and assumptions are made about the right answers, the implications are clear. And this is what Bill Tate wrote about this. The underpinnings of school mathematics curriculum, assessment, and pedagogy are often more closely aligned with the idealized experience of the white middle class. This is in the context of the United States. So here's an implication that I draw from this. If you're going to ask questions that apparently relate to lived experience, then how do you take into account the diversity of that experience? Which of course creates a problem for widely used textbooks and assessments. If you have a textbook which is widely distributed and used by a lot of students, how do you take account of the fact that those students are so different? And if you have an assessment, how do you take account? See, the problem, for me, one of the major things wrong with mass standardized assessment is that it's a very impoverished form of communication. If you think of assessment as a matter of communication, the person writing the item tries to communicate what it is they want, what knowledge it is they want the student to communicate back. The student reads the question and tries to communicate back to the assessor something about the mathematics that they know. The assessor then interprets what the student has written and evaluates it in some way. As communication, this is very impoverished. It's a one-time deal. The student does not get a chance to say, well, what exactly do you mean in this question? The assessor doesn't get a chance to say to the student, to ask for the student for a clarification. This is becoming particularly important in these days, where nowadays they are using artificial intelligence so the student can write a written response to a question, and that will be evaluated in some way. But if you don't have, if the assessor, or it may even be a piece of computer software that is doing the assessment, if there's no chance for further clarification, communication is faulty. What makes communication possible is that you can have several back and forth. You can discuss. So when someone asks a question, I can ask for a clarification, or they can ask me for a clarification. So you have back and forth, and that makes communication possible. Assessment as a form of communication, as I said, mass standardized assessment is a very impoverished form of communication from that perspective. There's a paper that Shobna will talk about later called Whose Culture Has Capital? Because there's this concept of cultural capital, which again, Shobna will elaborate on that. But cultural capital isn't, like other forms of capital, is not equally distributed. And some cultures have capital and others have very little. But as I said, Shobna will tell you all about that later. So one way that my colleagues came up with to describe what is going on in the classroom is that there are a set of, there's a kind of game which the students and the teachers play called the word problem game. And it has rules which are not written down, but which are implicit, and the children figure them out after a while. So you assume that there's only one correct answer to every word problem, and that this has to be an exact numerical answer. You assume that this exact numerical answer can and must be obtained by performing simple arithmetical operations on all the numbers stated in the problem. Well, sometimes there is superfluous information which needs to be ignored. And the last one is the most pernicious. Don't worry much if your knowledge about the everyday world doesn't seem to fit with applying simple arithmetic operations on the given numbers. So what could be done differently? First thing I would argue is that you should respect the child's and indeed the teacher's right to sense making. You should rewrite the didactical contract by the rules of the very proper game. For example, very simple. Oh, there's one other point I wanted to make about this. If you follow these rules, you will have a very high degree of success. If by success is meant getting high marks on tests, in most contexts, conforming to these rules will ensure that you get good marks on your tests. So a very simple way of rewriting the didactic contract is by saying to the students, it's okay when you read the question, if you think, I don't have enough information to give an answer, you can say that. If you can say, I can only give an estimate, it's okay to say that. If you think this question is just nonsensical, it doesn't make sense, it's okay to say that. And when I was reading your report, I was very struck by the degree of rapport that you have with your students. So you can have these discussions with your students, open discussions, and you can say, look, this is okay. It's okay to say, I don't know the answer to this question. The only difficulty I see is that you are facing two maybe incompatible demands. You want to share with your students. You want your students to have the right to sense making. On the other hand, for very practical reasons, you want your students to do well in the tests. And quite frankly, I don't know how you balance those two competing demands as a teacher. I'm thinking of one teacher in particular that we work with in Portland. He has great crisis of conscience because he feels that the system is forcing him to do things with the children that he doesn't think are good for the children. I think teachers are put in very difficult situations. And we can discuss this later. Above all, I would say adopt the modeling perspective. And that can be done from a very early age. Children can understand that if you ask them the question about Joe has 6 friends and his brother Jim has 5 friends, the answer, how many friends do they have altogether? The answer is not necessarily 11 because some of the friends may be common. That's not so difficult to explain. So, and I would say if you can help children learn to discriminate between cases where the model works exactly, where it is only an approximation, and where it is just totally inappropriate. And this is my final point. Everything I've been saying is political in the following sense. If children were to learn that models can be critiqued, perhaps they may start to realize, for example, that the amount of wealth someone has is not a matter of that person's intrinsic worth or contribution to society, but is determined by rules made by humans. And those rules can be changed. Thank you, and if anyone, this is my email address, I'd be very happy to interact with any of you who want to follow up, ask for references, and so on. Oh, okay.
Thank you, Brian. We now open the floor for questions.
I would like to share an experience after.
Yes.
Normally,
Maybe you want to stand up. It's,
normally when children come to us to school, they have a lot of mathematics in their real life situations already. But we start teaching them addition as 2 plus 3. We don't use what is there 2 plus 3 in their life. So the first thing we do is start from what is there in their life and good. For example, fractions, the children from tribal communities have fractions in terms of half liter milk and quarter liter milk because they have at least one cow at home. So start with what they have in their life. That is one thing which works. And second thing is we ask them the kind of modeling we are doing from situation to numbers. In the same way, we ask them to tell a real life story from numbers to real life, right from the beginning. So when they learn single digit numbers, right there, we ask them, tell me a real life story of 4. So it may be, I have 4 friends or there are 4 members in my family. And then when it goes on to additions and bigger problems, suppose I ask them real life story of 35 plus 10. One child may say there were 35 people on the bus and 10 more joined. So how many people are there on the bus? That is how children are creating different stories in different contexts. That actually gives them opportunity to connect to their problems. And after this one, I asked, give me a real life story of 285 plus 100. And one child again said, on the bus there were 285, and the other children started arguing that there can't be 285 people on the bus. So that is where actually it's also helping to develop their number sense and estimation better. So these 2 things of starting from their life and asking them to narrate real life stories works quite a lot or works quite well for
yes.
this.
Yes. Shopner will be talking about this to some extent. I always think when a child goes to school, they know a great deal about 5. They know there are 5 fingers on each hand. They know perhaps that they are 5 years old. If they are fortunate enough to have a birthday cake with 5 candles, they know the 5 candles. They know that there is one coin which is worth 5 rupees, but it is equivalent to 5 1-rupee coins. They know that a certain house in the street is number 5 on the street. They know that a bus can be bus number 5. They have so much, and they go to school, and this all gets narrowed down to 2 plus 3 equals 5. On fractions, I'm sorry, I cannot resist the temptation to talk about fractions. Quite young children are expected to be able to add 7/9 plus 3/8, which is something that nobody ever does in real life. If you talk to carpenters or engineers, they will use halves, quarters, 1/8, 1/16. If you have to add 3/16 and 1/8, finding the common denominator is not a problem. Either that, or they use decimal fractions and they use a calculator. So why students should be tortured with 7/9 plus 3/11. I don't know. I blame them. Personally, I blame the mathematicians. And I just said that to be provocative to see if I could get a reaction.
David, please.
Yeah, my question is kind of related to this. Which is actually, when you think about it, how do we learn things in real life? Is, there's something that we need to, like, we're wondering about, or for some reason we have some problems on stuff. So we might ask a question to somebody who we think could help us, investigate that
Yes.
question or whatever. But, and little children do that, but when they go to school, then it's a different thing. The teacher is asking the questions, the
Yes.
students are not asking the questions.
Yes.
But the most strange thing is the teacher already knows the answer
Yes,
to the questions
exactly,
that
yes.
they're asking.
Yes.
So, have you done any studies on word problems asked by children without being asked to ask?
Yeah. I haven't done any personally, but there have been such studies. The problem is that when children are asked to write their own word problems, well, Chopin knows more about this than I do, but they tend to mimic the problems from the textbooks. Sometimes they put in things because they are children. They say, John ate 12 worms in the morning and 6 worms in the afternoon. How many worms did he eat altogether?
No, but that's why I said without being asked to ask.
Yeah. Oh, without being asked to set word. No, I don't know.
Do they ever
Yes.
ask each other word problems as part of their everyday conversation outside of school?
I don't know of any such studies.
They
Do
directly
you?
solve it, as he said earlier. When they encounter a situation, they solve that situation, they solve that problem. They don't put it in words like a word problem.
Yeah, it may be an implicit question, but it's still a question.
There's an interesting piece of tape by a very well-known person who interviewed a lot of children. And he says to this child, "Do you know what 8 times 4 is?" She said, "No, what?" So this pointed out it's a very strange situation to normally when you ask a question, it's because it's a community, it's a speech act or a communication where you want the other person to give you some information which you don't already have.
Yeah, and actually you're headed for trouble if you really are going to allow children to question the questions, because actually there was one Calvin and Hobbes illustration of this just 2 or 3 days ago in the newspaper. They have this Calvin and Hobbes cartoon. So there was Calvin asking his friend Hobbes, what is he's trying to do his homework, saying what's 7 plus 3. So Hobbes says, I don't know. So Calvin says, oh, I don't know either. Yeah, that's the right answer. And he writes down, I don't know. That's the right answer for all of this. So, I mean, that could happen for the word problem.
Some of the best comments actually come from the satirists and the cartoonists. Yes.
So I guess what you're talking about word problems, sorry if I'm digressing from the issue of it, but sir, it's only limited to middle school, so junior school and middle school. So as we go up higher in our careers to high schools and also maths becomes abstract, and mathematics is taken as a subject which can make or break a career. It's not supposed to be understood, it's not supposed to be explored, it's not supposed to be questioned, it's not supposed to be engaged, but it just have to be read so that we can pass entrance test to engineering and medical.
Yes.
So when you go higher up and then you go to algebra, when we go to calculus, so it gets so vague. I mean, I don't know how am I going to use this. I have learned calculus in my class 11 12, but I haven't used it in my life anyway. So I don't know how it skilled teaching maths, otherwise if you have learned something else that would have been in the first place. So maths, do you think this subject is a certain kind of regulations about what we are trying to expect from students as in a class or a community, or the skills what we are imparting? Does it only fits into a system of our market-based economy, or we are trying actually to empower certain people out there? So what's the objective of mathematics in the first place?
Well, that's a good question. What is mathematics education for? One answer that Rossi would give is maintenance of an underclass in society. It's for the reproduction of species Homo mathematicus. And that's one of my, I think that's one of the key questions. What is mathematics education for? And should people ask that question? And the point about modeling, this may be a digression, but recently I have had some email correspondence with a mathematician who wrote about the Cold War period, when if you've seen the movie Dr. Strangelove, okay? So during the Cold War, there was the policy was guided by the so-called MAD, MAD doctrine, mutually assured destruction. So if both sides knew that starting a nuclear war would lead to their annihilation, then neither would start. He felt as a mathematician that this, well, he felt as a political person that this was wrong. He also felt as a mathematician it was wrong. He also felt very strongly that this doctrine was partly based on the mathematics of Neumann and the abstract mathematics called game theory. And he said, how could I, as a junior mathematician, argue against one of the great mathematicians? And I think this points to another fundamental problem, which is the authority that is given to mathematics. I don't know, is that kind of related to the question you raised?
Definitely, sir. As one problem, so when I was a child, when I was being taught in schools by my teachers, I was only told in what problems to do for numericals. You can ignore the writings, you can ignore the English language. Just look for the numericals and just understand what you want to do with it. And the really bright boys of the class, they used to pick, okay, man, this 12 into 4 minus 5, that's the answer. Okay, that's the answer. So there was no social implication of a word problem. The words are just fillers, and the numbers are only dominating your problem. So that was I thought in schools. So that's the way it is.
Let me interrupt you. Maybe there's a vast gap between your education and the scene which is going right now. There's a vast difference, sir, because in fact you can refer to many of the NCERT textbooks also. The things which are related to the students and the things which are going right now in their surroundings, many of the things are been included in the NCERT textbooks. Not only NCERT, but many of the private publications are also been included, because now there is what to say, people have realized that yes, there's only one way of teaching maths, and that is relating themselves to the things which are just in their surroundings, or the way the children are being related.
Yes.
So I think now there is a difference in what we have studied and what the children are
Yes.
studying very deep.
If you go to the higher classes, I don't
Exactly,
think there's a change.
There is. See, I'm not teaching to higher grades, I'm teaching to the middle school. But I've seen many of the questions related to trigonometry and all. The things are being taught in that. The examples which have been given in the books, the text and all, they are relating to their real life or the situations which they see around them. Okay. And if you are talking particularly about calculus and all, differentiation and all, frankly speaking, I'm not teaching those parts, but yes, I was also being taught the same way. It was quite abstract, and I still wonder, like, for what thing all these things have been used.
Yes.
So, as we are relating the mathematics to our real life in lower classes, the same thing should be related in higher classes too.
You know,
Or basically, or I can add up more things, the thing differentiation, integration, and all these things are been used by the engineers, if I'm not mistaken, right?
I have been an engineer and we hardly use it.
yes, that's right. There are many studies of engineers and architects, for example. Architects, a researcher spent a year in an architect's office. Apart from some very trivial examples, he saw no evidence of geometry. Engineers often will do without calculus. There's also another point. I call them the twin fetishes of the curriculum, algebra and calculus. Is that the only basis for a mathematical curriculum, aiming for the peak of algebra and calculus? What about statistical methods? What about system dynamic modeling? I have a colleague back in Portland. She has been working very much on her own for a very long time, teaching algebra in high school through system dynamic modeling, which actually has very important applications in terms of environmental studies, in terms of medical studies, etc., etc., etc. And because of the software that is available, it can be made accessible to high school students. But there is a degree of rigidity and inertia and the heavy hand of tradition on the what constitutes the mathematics curriculum. Okay, I think I should stop at this point. This is I have never done a session this long before, and I attribute that to your interactions. Thank you very much.
We will continue the interaction after tea. The tea is waiting for us. And we have many friends who have arrived today from Brazil and Greece, and many teachers from nearby cities. So we are really, really happy to have you with us. So let's break for tea and right here. Sunset. Let's target to come back around 4:15 for the talk by Mr. Mukherjee.
अभी के लिए लगा देंगे ठीक है ना ठीक है वो the thing is if we stop now we have to do it again like